Hello, everybody. Over there? Okay. So, how's everybody doing? Final project? No, not final project. What am I saying? It's final days of this not final project, right? Okay. All right. So, officially, I guess it's supposed to be due today at midnight. So, we'll use that as a sort of a mile marker. If you have a vote, I will start the grading Sunday. So I will give everybody one more day. Actually, you know what? I'm not introducing anything new. No, we'll one more day. So you get all of tomorrow. How's that? That's a pretty good bargain. That's a pretty good deal. All right. All right. So enough people have asked questions. And today is officially largely supposed to be, or I don't know if it says it in the, but in carrying on a tradition of the day before or the general proximity of the project being due, sort of prefer to make this a studio day. So make this sort of like Q&A, not really introduce anything particular new necessarily, but go ahead and try to cover, elucidate, maybe do something kind of cool to show some stuff, but not necessarily get carried away with a lot of stuff. So for those of you who are done, I may show a couple of things. For those who aren't done and are struggling with a particular area of something, or a particular approach to something, let me know. I don't necessarily need to be just streaming this whole time. I could certainly make it like, okay, if nobody asks me anything, I'm just going to keep working on this game that I sort of have here, maybe adding some new features to it. Or if anyone has a question about a particular sort of thing, I can show how I would implement that in my framework here. This is why my games never get finished, because I just add new features depending on whatever anyone wants to ask about. So my designs, I should go back and see what the original, I was supposed to have ghosts and ectoblasts and bandits and arrows and multiple arrows. So I guess I got a lot of that. One thing that was a late ad yesterday, and it was, I put a video specifically about this, about 12 minutes long, about the notion of, well, what if I'm not using the sort of, top-down RPG, JRPG kind of graphic, where the sprite walks up, sprite walks to side, and down, and so on. And instead, what if I was doing sort of the Asteroids style game, or what if I was doing sort of the boat movement and so on? And how would I rotate a character, rotate an NPC to make it sort of face the character? And I did it in one particular way. Someone has a really loud mechanical keyboard. I think, Alex, that might be you. But I hate to, I should encourage people to have their microphones on, but all our cool mechanical keyboards are going to betray us. So, and even the last thing I guess I posted over in the fall 2020 fall Discord channel was a little bit of an explanation and sort of even yet another simplification of this look at function that I had sort of created. So let me start with that for those of you who may not have seen that. And so the idea we've done with our enemy AI so far, we've had these enemy AIs where they would move towards the player according to a couple of things. Like, first off, they would have to see the player. Basically, it has to be, the dot product of the direction in which the NPC is facing and the vector formed by a line between the NPC and the player, right? We take the dot product of them to see, are they kind of close? Are they similar enough to consider the character be sort of facing in that direction, right? So we have to have a sort of a look at, there's some angle, some vector that our NPC is looking at, and we use that to determine, okay, can they see the player? And then, is there anything in between? Is there anything blocking that view? And for blocking the view, we would take a line that we would cast either from the NPC to the player, or clever hack was to shoot the line from the player to the NPC to see, is the NPC the thing that is, is there a clear line in between the player and the NPC on that particular NPC? And if not, we assume that, okay, something else is in the way. So if those two things were met, then we can say, okay, the NPC is aware of the player, right? And we could generalize that, maybe just say, okay, rather than our code that said, okay, it should immediately start walking towards it. Instead, we could say, well, let's make that awareness, right? So now we're saying, okay, here's another thing to say, okay, if the NPC is seeing it, should it turn towards it, right? In another case, we just had it move towards it because they were sort of, again, sort of JRPG top-down, Enter the Gungeon, kind of style characters where they never really faced, or they faced in a direction by direction of their sprite, but they didn't actually rotate, right? The direction that the sprite image is facing determined direction, as opposed to some kind of orientation or rotation of the sprite. So that was where the big difference was. All right, I just said a whole bunch of words. Let me show you what I mean. Maybe it'll make some more sense. All right, so in the game here now, I have these spiders, and normally I have these spiders that sort of just moved up and down, and I didn't yet animate them to make them kind of move in the right direction. So instead, now we're going to take a shortcut and say, well, okay, I've got this spider over here, right? Put this spider in. I created the spider, and one thing I like to do when I'm going to rotate something like this, when I'm going to rotate a sprite, is I like to orient the sprite in the same direction as the up vector. Okay, so that's why I took the spider sprite here that I put on this monster, and it wound up being flipped. You notice it's not actually rotated at the moment. I don't want to rotate it because I'm going to be doing other things to do rotations. So what I was able to do is say, okay, flip it in that direction, right? So I flipped it so that it is facing up. So now I know that if I were to rotate this spider, the idea is that the up vector, kind of what the local up vector, at least, the kind of the local rotation is going to determine that direction, right? So this character, this thing, has an up vector which corresponds to this right here. Now, let's see. Let me get the rotate tool, the scale tool. All right, so now let's see. Can I do this? Okay, I've got that rotation. Never mind. I'm not gonna do it that way. Oops. Definitely doing 190. 0. All right, so back here. Oh, I see. Oh, that's what it was. See here? Okay. Here's a good one. This is gonna make a lot of sense in a moment. Notice the toggle tool handle. Get this toggle tool handle rotation. Tool handles are in the active object's rotation. See, local tool handles are in the active object's rotation. So watch this now. Okay, so let's go ahead, select the monster, and be in local mode here. Now, if this is working, you'll see now as I rotate if I change my Z rotation here, the green arrow, which is up, is actually rotating with the sprite, where the sprite is rotating with that, right? That's because now that up vector, we're showing it the local version, which means the world from its perspective, as opposed to the global, right? Tool handles are in the global rotation. That means the whole world, we don't want to change the orientation of the whole world. So if we switch this to local, we're looking at it in terms of the local position. Now, the up vector of a transform is its local version of that. So keep that in mind, right? So we're going to be dealing with this local rotation and this up vector, which gives us a local reference. So we're going to go ahead and let's look at NPC lookat, pardon the pun. So we want to create something where the NPC looks at the player, right? And here's how we're doing it. So we consider it to be looking at or looking in this up direction. That's the direction it looks in. It looks up. We just assume that. So we want to change that up position according to where the player is, right? Here's the player down here. So to find the direction to rotate to, or the direction I want to face in, you may recall that we can subtract these two, and we wind up with a vector that points from one to the other. If we subtract two locations, we get a vector that points from one to the other, right? And a vector is a direction and a length, a direction and a magnitude, okay? Vectors are direction and magnitude. So if I know the vector in between these two, I know the direction and the distance in between them. Important stuff. So for the first thing, if I want to do the rotation, I want to take advantage of that direction to say, okay, I know I'm already facing in this direction, right? If I click on my monster here, it's facing in this up direction. That's its current direction. And I want to be facing according to this other vector here, okay? So the target vector, we've seen this before, right? Is just the difference. It's a line, it's a vector that I subtract the hero's position, or I subtract the NPC's position from the hero's position. That gives me that vector. So let's do this. Just to illustrate that, we could say debug draw line, and we're going to have a start and an end. Easy enough to do, right? So the line that we're going to draw, the start is the transform position, and the end is the hero or player's position. And we can give it a color. Color dot, we're going to make it green. Okay. So that is the direction that we want to be facing. That would be the ideal. That's the target. Let's have another one, which is we're going to draw a line from the player's position, or excuse me, from the NPC's position, but we want this one to indicate where it's facing, right? So the point that it is facing currently is, we'll say, okay, it is actually, we're going to use its current position, because I know it's I can do an offset from that position, right? So I take that position and I add transform.up. And this one I'm going to color yellow. Why not? Okay. So I'm going to have one line, a green line that is going to be pointing from the NPC's position to the player's position, and the other one points from the NPC's position to the position with an offset, right? The direction it's looking in currently, right? Now, if I go ahead and just do that, we will see, pay attention to our bug there. Come on, Unity. So you hear the fan running on my computer right now. All right. There we go. Come on, Unity. You're hearing my wife talking to the cat. Okay, so you'll see now, here's the spider, and there's a green line from the spider always to the player, and the yellow line in front of it. It's 1 unit away from the bug. I can make it even more, like if I didn't want that line to be drawn all the way over here, I could say, well, let's normalize that. So we will plus transform position. So we're going to say hero, draw line from here to here. Well, let's see. I would say, can I say draw ray? I'm going to do that. Draw ray, which is going to be from this position. And instead now I'm going to draw my target vector, right? So now my target vector, and I can even do this. Let's say instead of drawing this line, I will draw a ray from this position. And what that basically means is I can say, get rid of this position term, right? So now I'm drawing rays, right? I have a start point and a direction. So I have a start point and the direction. The target vector is where I want to be facing. The transform dot up is where I'm currently facing. We'll do it again. Of course, Unity was quicker. All right. Let's see. Whoops, I'm still getting a line. Why am I still getting a line? Oh, I know I'm still getting a line. Okay, well, here's the thing. And this is a good point. The target vector right now is not a unit vector, right? It is the whole vector. It points the whole distance. So if I want it to be just direction, I want to eliminate, right? Because vectors have a distance. They're basically a direction and a distance, direction and a magnitude. And I want to set the magnitude of this to 1. So I can just say target vec dot normalized. So give me the one that's only 1 unit long. And for now, just to make life slightly less crazy, let's turn off my game manager so we don't wind up with a million, or at least we'll turn off the populate dungeon script. And we can, I think, get rid of all of the orcs on the screen. This is, hopefully I don't live to regret this. Let's see. If we get rid of these orcs, and did we get rid of all of them? I don't see any left. Good. Made my life much easier now. So we should now see a line drawn from the spider to the player. Okay. We see the green, which is the target, and the yellow, which sort of, whoops, lags a bit. We do see the ghost. I should turn that away. I'm trapped. All right. Now the mole will see me. Okay. So as I move, you see the difference between those two. So how is it adjusting that? The adjustment is pretty simple. So these are the two vectors. I can see them now. One, the target vector normalized, and transform dot up. So I want it to be facing in this direction. Sorry, let me rephrase that. I want it to be facing in this direction, this direction, the target vector. That's where I want it to face. But here's where I'm currently facing. So our good old friend LIRP, linear interpolate, right? we can interpolate between these two vectors, the one I'm currently at and the one I want to be at. And we're going to use the good old Zeno's paradox trick. All right, Zeno's paradox means if I'm standing at a certain point and I move some portion of the distance, could be anything, could be 10% of the way or half the way, right? As long as I keep moving towards something, even if technically I never get there, I'm going to get really close to it. So that's what I'm going to do here. So even though I'm not going to interpolate across a specific amount of time, I'm going to interpolate from my current rotation, which is transformed that up. I'm not actually moving, I'm rotating now, right? So I'm going to change this vector from its current up towards the target vector, which is then normalized, right? So I'm interpolating from this vector towards this vector by some amount, right? Why do I normalize it? Because I really just want to change the direction, right? Transform.up should be a normalized vector. It should just indicate direction, right? So I want to interpolate in between. It probably would work, to tell you the truth, if I didn't normalize it, but it's good practice when if you are only concerned with the direction to normalize vectors, right? So it's a pure direction, right? So I'm going from pure direction up to pure direction, whatever the target is. Now, this term here this is the knob that I'm turning, right? And this is where, normally it would go from 0 to 1, right? If it's 1, it means give me this value back. If it's 0, give me this value back, right? It could be right here. Now, the thing about this is getting called an update. So it's happening over and over and over and over again, probably 60 to 144 times a second, depending on which monitor I'm running on my computer, right? So to get this to not immediately snap to that direction, I do this, right? I say, okay, in the fraction of a second that occurs in a frame update, I'm going to move towards that by some amount. And we can count on this number being usually pretty darn small, right? It's the amount of time it took to draw one frame. So it should be a 60th or maybe 144th of a second. But it's going to be some small number that kind of makes our call very consistent. But what I'm going to do is say, okay, in that amount of time, how much should I move towards, what percent should I move towards this target? All right. So if I just set it to delta time, turns out that is really small, a really small amount. So it takes a long time to get there, right? The smaller this amount is, the less of this one I'm mixing in, the less of the destination. And the closer to 0 this is, the more I just get this value back. If it's 0, I just get this value back. If it was 1, I get this value. Small numbers favor this. Larger, getting closer to 1 favors this, right? That's the way the interpolation works. It's moving me between these two values. So to make this speed up, I just multiply it by some factor, the speed that I want it to kind of rotate at, right? If I figured out, okay, I run at about 60 frames per second, if that was true, I could kind of multiply this by 60 and it would snap there real quick, right? Because it would tend to be 1. And I don't want it to snap that quick because it's basically, if I set this to this times 60, right, it would move all the way there in one frame update, right? Because it would say, okay, delta time, that's the amount of time in one frame update, times 60, that would give me 1 second if I was at 60 frames per second. So this would become 1 in a single frame update, meaning go immediately to this in that frame update. That's why I don't want this to be too big. 60 would be too big. I don't want to move there all the way in one frame update in 1 second or one, yeah. It's kind of a little bit weird in the math. Exactly. That's called fixed update. That's the fixed update routine. Update gets called, remember, update gets called once per frame, right? So on a computer that is running 60 frames per second or thereabouts, I'll get 1/60th of a second there if everything's running well. If my computer was refreshing and I was getting 144 frames drawn per second, this number would be even smaller, right? And the idea behind this is so that I can scale. If I want to do a certain amount of work in here, by multiplying it by this, that lets me say, okay, no matter what that was, I'm scaling it by that amount, right? So I'm able to kind of get it to smooth out, right? Because if I didn't have that, if I just said 0.01, then it wouldn't matter. It would actually move. Or if I said 0.1, imagine I said 0.1. If I said 0.1 here, it'd say, okay, every time a frame is drawn, move 1/10 of the way towards that, move 10% of the way, right? So if I was running at 60 hertz, after 1/6 of a second, I'd be facing that way. If I was running at 144 hertz, 144 frames per second, well, after 14 frames, I would be facing there, right? Because time delta time would be smaller, so I'd need to scale this. That's why I'm doing that scale. So I say, okay, move closer, but factor in time so I don't immediately, right? Without this in there, it runs too fast. So okay, we'll leave it at that now. So I set the result, or I use that result to update transform.up. That's what gives me the rotation. Modifying transform.up is modifying the local rotation, the local orientation. Right? Now, every time this gets called, transform up is changing because I assigned a new value. So the next time this is called, I'm starting at a rotation that was closer and closer and closer. That's the Zeno's paradox, right? That you're always taking half the remaining distance, not the original distance. You're taking some portion of the remaining distance, right? If you only moved half the way between the original distance, then you'd get there in 2 steps, which we don't want to do. We want to move half of the remaining distance. That's the Zeno's paradox part. So that's what gives us that kind of smoothed out. We get there over some course of time, and that's what happens. All right, so that's what the spider up here is doing. So you'll notice it's pretty quick, but not ridiculously quick, right? There's some difference in the. Oops. I always try to use the scene window as if it was the gameplay. All right. So now that's happening no matter what, right? Even though the bug starts off facing in the upward direction, it assumes it immediately sees the spider, the player, which we may not want to do. So let's use that same logic we had before, where we said, okay, we should only be moving towards this if we could see the player, right? So rather than stumble through it and bump through things, let me look up, okay, pre-made version. This is the one where I had NPC behavior, where we would go ahead and move, right? It's the same idea where we're saying, okay, I can figure out the direction that I need to move towards the player by interpolating from the current position to the position of the player, right? So this is how I did the movement last time. And I said, okay, during every frame, move 0.1. And this one, yeah, I didn't factor that in. So it would be, they will move faster on some computers than they would on others. So here's the bug. I should put the time delta time in there. So on this one, we were saying, yep, do the position. But the logic up here is the same, right? The logic up here was what we're interested in. We figured out the mask So we can figure out, and the target here. So we figure out, okay, we want a target, which is from the hero to the, or from the NPC to the hero. We say, okay, oh, this one is pretty good. This says, okay, if you only move towards the player if you're already not within 1 meter of the player, right? So it actually doesn't try to move towards the player if you're not within 1 meter of it, if you're not already within there. So it kind of keeps a little bit of social distance going on there. So that's an extra step, bonus step for that. But then here were the other parts where it said, okay, am I within the field of view, our vector2 dot product between the current view, which in the case of our other things, oh, this was an older, gunkier version. All right, let's grab this and let's make it work for the other one. Let's go ahead and just make it work rather than try to explain it in this context. So let's grab that. And I'm going to go ahead and say, okay, so during look at, I'm going to get rid of the slightly older version of that as well. So this is what I want it to do, but I haven't given it any circumstance to do that in. So in the interest of flexibility here, we're not going to put it in update, or we're going to put it in update, but we aren't. So we say void, and we'll call this detect. Actually, we're going to do this bool, right? It's going to be true or false, and the function is going to be called detect player, right? So detect player. Not all code paths return a value at this point, right? You'll notice there's no return values here. So let's assume, for starters, let's put in a return false. Means I can't see the player. So that's my default value, return false. But let's figure out, okay, when would we see the player? Well, in this other code here is where we decided to actually do the movement. So let's assume that's where we want to return true. And we're going to make this, streamline it just slightly because we really want it to be detect the player. So you can shout out some suggestions in a moment if you like. So detect player is going to say, all right, do all our normal stuff. It's going to say, first, find a target based on the current object's transform and the hero's transform. Assume that there's some line of sight if you're within 0.5. And then we've got some graphical debugging. We'll get rid of that. Then we're going to say, all right, draw a ray from the current position to, or in the direction of the target. So let's see. This was the, I guess this was the less exciting version. I like this newer version where we would cast a ray from the player's position, cast a line, excuse me, from the player's position to the transform's position. Clean that up a little bit. So we go ahead and we cast our ray from the player's position. Whoa, what happened? Too many things got taken out there. Okay. All right, I think that, yeah, there we go. So the line goes from the player's position, the hero's position, to this NPC's position, according to the layer mask, right? Obstacles, enemies, and the player, right? In this case, I'm going to get rid of the player. No, I do want to be able to see the player. Of course I want to see the player. No, I don't want to see the player. Whew. Why don't I want to see the player? Because I'm drawing from the player to the enemy. So that I don't want the player to see himself, right? So I want to see, would the player see me with a straight line? Okay. Here we go. This is better. So we have a ray cast, or a line cast, excuse me, from the hero to this guy's position. And we see, okay, is the thing that it hits, if it hits something, and we'll do this, we'll say thing I hit question mark, meaning, can I do that? I guess I can't. So just to be careful, I'm going to say if thing I hit, if, be just kind of careful to make sure, okay, did I hit something, meaning thing I hit was true. And then if I did hit something, then I check to see, was it me that I hit? And, all right. So here's my detect player now. You say, okay, can this NPC see past any obstacles and enemies? Or can, it actually really is sort of, it's logically a little bit backwards. It's, can the player see this NPC? But it winds up being the same thing. All right, so let's go up here now and say that this should only happen if detect player was true. So if we detect the player, we can do that. So, a moment of truth. How many of you think this is actually going to work? I should have a poll. Let's see. I should have more faith in myself, right? If I have no bugs, okay, notice it can't see me. But still can't see me. All right, so something didn't work. So let's debug. Now, no compilation errors, but detect player, if detect player equals true. So what happened? So let's put a breakpoint in here. All right. Say attach to Unity. That's good, so it can remind everybody how to actually do debugging. And we're going to say play. So what should immediately happen is I probably will immediately break. All right. Because this gets called over and over again. And so as expected, if I do step over, it's going to say, okay, yep, it couldn't see me. No big surprise there. So for now, let's assume that we're going to get past here. Let's assume, hey, maybe the dot product works. Maybe this part works. So if that part works, I'm going to get to this line. So let's continue with a breakpoint on this point. All right. So let's see if I get past, whoops. Oh, somehow I got there. Interesting. Transform right normalized. That's crap. I don't want that. That line is bad. All right. Why is that line bad? Well, that is not transform up, is it? So this was left over from some code where it said, okay, I'm detecting based on some object that points to the right, right? I could do this exact same thing, but said, okay, instead of, this is why consistency is sometimes a good thing. I could have set this up so that the NPC was using the right direction instead of the up direction. That would be the red axis, if I recall, instead of the green axis. So that must be my bug, I'm assuming, because when I moved up there, it was pointing in the other direction. I probably should double check in here to make sure I don't have transform up or transform right used anywhere. No, it's just, now it's up. That should be good. Yeah. So let's say continue. At this point, we might have, yeah, let's restart the game. I should turn off that that ghost. Those ghosts are real pain. There. All right. Still nothing. Still that guy can't see me. All right. So let's see what's going on. So we got to the point where we're in here. So let's go ahead. Probably be better just to say, let's well, we're casting a line from the hero's position to the NPC's position according to layer mask, which is obstacles and enemies. All right. Intuition is telling me, ooh, I better check to make sure I put that on that layer. And in fact, I did not. So that's my problem. You can't cast and assume it's going to hit anything if it is not on there. And the ghosts are crazy again. All right. We're getting there. Say continue. Oh. Nope, still not. So what happened here? Did I not change the right thing? Enemy. And we got past here. We went from that position to that position, according to the layer mask. Thing I hit, collider, game object. So let's do that. And this time we'll remember to turn off the ghosts beforehand. And all right. All right. Thing I hit. In this case, I can come down here. This is a nice debugging lesson here. Okay, thing I hit. This monster spider. All right. So I did hit the monster spider. So the question is, monster spider 0. Why is that not? So let's step through now. Right? Step. Thing I hit. Suddenly, thing I hit is null. I thought a moment ago it was monster spider. Let's go continue. All right, it happened again. So thing I hit. I'm not hitting anything. So where am I here? I am here. The monster is facing the wrong direction. All right, so that's to be believed. So let's pause the game, or we could say continue. We're gonna have a hard time doing this. Stop that. Come over here. Some good debugging lessons here. If anyone has anything about their game that they want to see me talk about instead, you can totally feel free to derail my rambling here. Okay. Oh, it's not one to share with the whole group yet? Okay. So let's see. I'm going to go ahead and move the player here right in front and see what happens. So I'm going to come back here and I'm going to go ahead and put my breakpoint back in. Right. That's the nice thing about pause. I can pause the game, move things around in the game, and say, okay, that should be happening. So I'll set that up, and now I'm going to hit turn off pause again. And the question is, okay, thing I hit is collider is null. All right, I'm going to try to do this the easy way. I'm going to go to mole behavior and see what did I do there? Why isn't this working? Because the mole, I got this to work, right? Hit target collider game object, transform position. It sure looks as if that's the same, isn't it? Game object find hero and so on. Thing I hit. Raycast hit 2D. Target. I'm going to do this. I'm going to cut this much code just to compare to here. So, hit target, physics 2D, line cast, game object hero, transform position, layer mask. And this one we just specifically went for get mask. Did I? Yeah. Layer mask, get mask obstacles, get mask enemy, hit target, equals true. Thing I hit, that should be the same thing. Hit collider, hit target, dot game object. Sure looks similar. Now this I don't need to normalize because transform up is transform up. Is that another row? this case. So I'm going to stop the mole, stop everybody. Make my life easier. Let's turn off the moles. There's that other mole. Turn off that mole. And even, what's that other spider? We'll turn off that other spider. Not that one. That one. We'll get rid of that one. All right, nothing but us and that thing now. All right, we hit that point. We did not hit it. Why is that? What am I doing wrong? New unread. Someone's going to point out and be like, oh, you know, you just forgot. Nope. There is at least one weird situation. Well, I'm not actually doing the rotation yet. So okay, let's put our player. Now we do this cheat just a little bit more and say, all right, that should surely be seen. I hit play. Attach to Unity. All right, we got there. From start to end. Maybe the weirdest thing. I'm just going to do this. This is magically work. I'm going to be like, well, I don't know what. Never do live streaming. Oh, wait. Oh, no, I did actually. It's there. I just didn't share it. Just to embarrass myself further. Here we go. You want that? There we go. By myself. So usually when I walk around the room and say, all right, what did I do? So all right. Yeah. I'm like dancing in front of this thing. Well, the one thing I didn't think about, let's see, is, let's see, the player certainly has a box collider on it. The player should certainly, I'm going to be, you know what? Oh, I'm about to like smack myself for doing this. Ready? This is I can't believe I did this because I fixed the other spider to not. I never put a collider on this spider here. That's what I did. I never put the collider there. And if there is no collider, it's certainly not going to collide with that. So that's exactly what's happening. All right, you have to have a collider in order for there to be a collision. What made me realize that? I don't know. It just popped into my head finally. I don't know if there's a problem, but angles in Unity are only positive and from 0 to 180. You can use signed angle or just angle. By the way, someone asked, there's a signed angle and angle. If you want to the angle between two quaternion dot angle. I'm not even sure what you mean by that. A quaternion is a angle and orientation. So it's an orientation and an angle. It's a rotation. So in and of itself, if you're trying to just get, I don't know what the question is over there. So anyway, this is going to work now. So then we can move on. Moral of the story, make sure you have a collider on an object if you're trying to detect a collision. It'll help. It's useful. All right, let's get this to work so we can move on. So the goal in all this, while Unity is sitting here doing this, the goal was, of course, to create a function in here that I could then just say, okay, this is my detect player function here. You know, is it, let's see, let's hit continue. Yep, it's returning true all the time now. It's happy. All right, there it is. So that was the problem. Now the cool thing, you notice I snuck past, and now it's not rotating. Why? Because it can't see me. Now, it might be able to see me over here. Nope, didn't see me. Didn't see me. Can't see me. I can sneak up on it. Shoot arrows at it. Ah, it sees me now. So once it sees me, then it rotates. But if I, careful, I'm running around here. Nah, sneak behind there. It doesn't know where I am. Oh, it saw me because it was close enough. But if I run down here, it can't see me, can't see me. Sneaking up on it. Oh, I died because I hit the wall. Walls cause pain in this one. All right. So there it is. There it is. That's what I did. How did you spend your afternoon? Realizing I looked foolish trying to collide with something that had no collider on it. Happens to all of us, right? Yeah, the problem was because I had that other spider and I had gone through the process. I think so many things in the scene already had colliders on them and I forgot. I was just adding that. Yeah, this other one, or it had rigid body on it. I don't know if the other one had a collider either. All right. So if I wanted to now, I'll just leave this, as an exercise to say, if I wanted to, there should be particles. Oh, particle or explosion. All right. So in the idea, like in this game, I had instantiated an explosion anytime I shot at something, right? So let's go ahead and we'll put some enemies back in now that I spent all that time doing that. So the idea is, okay, when you hit something, use an explosion, use a particle system, use something. So let's go back. We'll turn on the game manager, populate the dungeon. So now we're going to wind up with random NPCs, and I'm going to shoot at them. And you'll see that they explode. They have little explosions. So instead of an explosion like that, let's use a particle system. right? That explosion was done with an animation, but let's use a particle system. Particle systems are really cool. What particle systems are, it's a way to generate we'll call it a trivial game object. You create on the fly all these, game objects, right? So it's a way to instantiate little things. They're not really game objects, but they are little objects with a life of their own. So let's create one just to see. All right, so I'm going to come over here, and in my scene, I'll right click, or instead I will say game object, create an effect. I'm going to create a particle system. Okay, boom, particle system. And look, it looks kind of like an explosion. So I've created this particle system. It's created an object with a particle system on it. All right. So let's move it somewhere just out of the view of the player there. Right. So particle systems are really cool ways to do things like explosions, fire, smoke, all sorts of different type of effects where basically you have like a whole bunch of quote unquote particles that are controlled as a system. There's some way to algorithmically, right, to parameterize the creation of these particles. Now, I don't know, hopefully you'll be able to see this. It's kind of a lot of parameters. Particle systems are complex and they have lots and lots of potential parameters. So by default, you wind up with a, kind of a particle system like this, which is shooting particles up, right? So again, to create that, I just said within the scene, I created a game object that was of the effects, and I did a particle system there. You can add particle systems to other game objects as well. Like if you want to add to the exhaust to a car, or even in one game, I added a little dust for the footstep effect on my little character. But let's use it for explosions right now. Let's make it easier. So what I'm going to do first off is I'm going to say, okay, don't loop, right? Because I want this to be an explosion. I don't want it occurring forever. So watch this. I can, see there's a particle system. I just said play, and I can hit stop, right? So I can always simulate it. The duration, 5 seconds. Well, I don't want it to be 5 seconds. I want a simple 1 second explosion, right? So that should happen. And you'll notice here lots of parameters. You can explore these for days if you want, but we're going to hit just the highlights of them. All right. Duration of 1 second. It's not going to loop. It's going to happen immediately. There's no start delay, and we can kind of ignore some of these. What start lifetime means is, okay, particles will live for, well, I guess they want to live for a certain amount of time. We're going to only have them live for 1 second, and their speed is 5. So they start off pretty fast. So right, this is how long they live and how fast they're going when they start. Okay. Starting size. Their size is 1. We can make them very small when they start. 0.1, for example. Maybe we even slow them down. 2. So I'm going to go ahead, hit play. Pew, just a little thing. They're just really small, and they move a little slower now. Maybe 0.1 was too small. Maybe we'll say 0.5. Play. A couple of particles come out. Sounds cool. We have the simulation, the speed at which it runs, and so on. Maximum number of particles. Play on awake. What play on awake means, start just like an animation or a sound. Play as soon as you come into the scene. Now, one of the most important things, or two important things, I should say, is the emission and the shape. Okay. Now, if I click on shape, you see over here, this is the shape of the emitter, right? The shape of the system here. So it's pointing things up. It's a cone, right? That's why our particles all kind of shoot up in that direction. So I'm going to change that to set it to its hemisphere. I could set it to a sphere, which might be good for an explosion. And I get to set its radius So I can tune its size, its radius, its the distance, and so on. We're just going to, you can go ahead and play with all those, but let's just set the big one, sphere. And I hit play. And they all go in all directions now. All right. Fire drill. Yikes. All right. It's a good thing this is recorded on, or at least it's on YouTube. So now we have this kind of nice little explosion there. Now, you'll notice they don't start immediately at the center. Why? Because of this radius. So let's take this radius and set that to 0. So now they're all emitted right at the center, right? And it's 360 degrees around. Well, let's see. Maybe we wanted a little bit more particles, right? So now we want to talk about emission. That's how they kind of, how they're generated or how quickly they're generated. Their rate over time, 10. Let's set it to 100. Okay, so they're emitted very quickly for that 1 second. Right? Now, you can see where we can start to, tune this up a little bit. So now, because there's so many of them, maybe we set them to be smaller, and maybe they should start off faster. Right? But now, because they start off faster, they travel further in the same amount of time. So maybe we want their lifetime to be smaller. And maybe we want their lifetime, the duration of the emitter to be 0.5. Start to tune all these parameters. In fact, that's probably more than adequate for a little explosion. We'll even have them live half as long, these particles. Now, if we really wanted to get into particles, particles can also have different types of shapes, different types of renderers. You do all sorts of things. Like I said, there's lots and lots and lots of parameters here, including the renderer down here. So right now, we're using a default material. You can create your own materials, your own textures, your own, look and feel. How are they used? How are they, what are they, images? Like if say you wanted to burst into a whole bunch of leaves or flower petals or sparks. And if you had the graphics do that, you can do that. But for now, we're keeping it basically basic. So we have this particle system. Hierarchy, we had our particle system. So let's name the particle system particle explosion. And let's create a prefab based on that explosion. All right, so grab that one, drag it in here, and delete the original. Okay, so now we've got our particle system, particle explosion sitting here in the bank, ready to do something. So let's go to our player, right? And just as the spectacular moment, because our hero here doesn't have that great of a death scene, right? So maybe we want a, tremendous death scene for our hero here. So go to the hero controller. We have the "you died" kind of thing. And who knows, maybe we'll want to make this even more spectacular. So we will create another reference to a game object, and we can do this with serialized field if we want. All right, because we're not going to actually access this by anything else. Explode death. So explode death, that's going to be our explosion. And when do we want that to happen? We're going to have it happen at the same point at which we had you died, right? But now in this case, we're not going to turn off the timescale. We're not going to end the game, because if we did, that would also stop the particle system. So instead, we're going to instantiate Explodeth. So we instantiate Explodeth, and we're going to instantiate it right here. So we're going to say transform dot position and transform rotation. And one of the things we're going to want it to do is we don't want it to live forever either. So we can say destroy the object that we instantiate. We're going to destroy it in 1 second. We know it's not going to even live that long, so fine. This is how we're going to just create that explosion. We instantiate it. It appears, blows up, it disappears in a second. So, real simple use of particle systems as an explosion effect. And let's hit the game. See if there's a mayhem breakout. Wall a bunch of times. If you have any life left. I'm almost dead. Oh, I have a bug. What is the bug? Again, we're hitting all the classic bugs today. This one is that I forgot to set Explodeth according to the prefab. Now, interesting. Now I've got two options. I have my particle explosion, and I have my explosion up here, which is an animated death. So I would actually have the option to use either. So let's go ahead, of course, since I went to that trouble, and we will put particle explosion as this particular type of death scene for the player, right? Come on, guys, attack me. Wipe me out. Now, because I'm below that, every time I collide, I'm technically dying every time. Let's do this. Let's take our same explosion, and we're going to use that explosion on our orcs. So we can come over here. Here's our orcs. Normally, our orcs have a... Where's their... Oh, did I do that in a flow machine? Add random force. Other flow machine. Walk towards... Yeah, this one instantiated explosion. So instead now I can come up here and say, okay, instead of instantiating explosion, let's instantiate of all the assets in our project here. So particle explosion. Okay. So now with that in our orc prefab, that becomes the new explosion for our orcs dying. All right. That's a super, super brief introduction to particle systems. Now, Jack, you had a question? John. Oh. Okay. Well, the good news is it's just parameters for the most part. That's the biggest thing in your particle system is sort of like, getting a feel for kind of what the parameters are like. Say, oh, I want it to be kind of wonderful, smoky, maybe a orangey, brownish, ugly, whatever. Just tweak that one in my prefab. That's the nice thing about prefabs. Control S. I'm a big fan of controls, Control X, Control C, Control V, all those. Which? Where it instantiated, I changed it so that I didn't stop the time scale. That's the only thing I changed. And instead, what I did is I instantiated the explosion at the current object's location with the current object's rotation, and I wrapped that inside of a destroy, right? Kind of, some people would like to do it. I'll show you this way. Meaning that, okay, there's a destroy function that is being passed this instantiate, and here's the second parameter of that. If you wanted to be, I suppose you could do that. Some people like that sort of code layout. I don't know. In the case of where you're doing something fancy, like passing the result of one function to another function, sometimes you do that just to make it a little bit more obvious what's going on or more readable. So you know that this is that function call. Okay. 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 Yep. The instantiation of, putting stuff on the screen. All right. So I have a function called, or a game manager here, right? One of the jobs of the game manager is to populate the dungeon. So the populate dungeon call here is designed to randomly generate spiders and orcs, right? So even I parameterized it here. So I say, well, okay, create up to 10 spiders and up to 10 orcs. And what I'm going to do is I'm going to have the spiders are going to be sort of central to the screen, and orcs are going to be potentially further out. So I gave them a bit of a range here as well. So now I can just say run that, and you'll see if this is enabled, I wind up creating somewhere 10 or fewer spiders and 10 or fewer orcs there. All right, they're all going to do their thing. So how does my code do that? All right. Now they are prefabs. First off, that's the important part, right? So I have, prefabs for spiders that have all their know-how built into them as they are right now, and prefabs for my spiders, my orcs and my spiders. Yes. So here I have orcs and wherever they are, spiders. Okay. So in my code, I have set up some serialized fields. That's just so things show up in my editor here, so that if I wanted to let someone design their own game with more, or I wanted to design levels, I could use this same script on a different level if I wanted, or if I could even do things like, get better with the, range. So if I wanted to create a dozen spiders in this one corner, I could make a special populate routine that would do dozen spiders or dozen whatever they are at this location. All right, so why don't I do that? I'll kind of, let's generalize this function a bit. Okay, so I've got the populate dungeon function. And right now it does two kinds of prefabs, but let's streamline that. Okay, in the interest of streamlining it, we'll just have it do a single type of prefab, right? So I'll take out the second one and I'll get rid of all of this. And I'm also going to add some things. I'm going to say, this is going to be, instead of mob1 range, this is going to be mob1 corners. Mob corners, mob count, mob prefab. Okay. Now by corners, I actually want to have, we'll call this one another fire alarm. We'll call it corner 1, and the next one will be corner 2. Okay, mob corner 1, mob corner 2. So we're going to go from -3, -5 to 3 and 5. And we're going to call this mob corner, mob corner 1. Mob corner 2. So it gives us our X range here, according to, it'd be -3 to 3. And then we're going to have mob corner 1. Corner 2. All right, so let's break this down a little bit as well. I'm going to make this a little clearer here. So I want to figure out, now first off, you'll notice this here, random init state 42. And this init state 42, random init state, this is establishing a seed to the random number generator. And that's so that the mobs always show up in the same spot. So every time I run this, this random will have been initialized from that specific value. Now, I probably don't want to do that in here anymore because populate dungeon is going to be called, I'm going to use it a bunch of times. So for now, let's take that out of here, and I'm going to put it in something that I know is only going to be called once. So I'm going to go to hero controller, and inside of awake. Right, so as soon as the hero awakens, hero is going to initialize the random number generator to this magic number, so that even though my game is kind of populated randomly, it's going to do it the same every time, right? So it gives me randomness, but randomness the same every time. I don't know where it's going to put all those until I see it happen. Then I can see, then it's always going to happen, right? So that's that. Yes, because the random is a library that's shared throughout. Now, you're not going to get the same, this is the seed. So this is, the starting number, right? So we're going to seed the random with this. Throughout the whole game, you're going to get a random number every time, a new random number every time you call one of the random functions. But this is going to establish the seed for the whole game, right? It's like when you in Minecraft, right? We've all played Minecraft. You have a world that seems to be randomly generated, but you can get a seed for that world, so it knows, okay, start with this number and then randomly generate everything, right? So that's what's happening here. That's why I only really want this init state to happen once, because that's the initial seed for this particular scene. Now, since this is in the scene, other scenes in the game will be entirely random and different and so on, but this particular scene will be predictable as that. All right, so there's that. Now I've got populate dungeon, and we have the corners that we want our mob to appear at, the prefab we want to use, and how many we want there to be. All right. So let's save that. Now this is let's talk about what it's doing here. So where should we try to spawn? Right, I pose is just a vector2, an x and y position that we want to try to spawn at. Right, it hasn't been saved. It's just a holder here, and I could. I'm always cleaning up code, right? I can put it in here because that's really, it's used just within this scope, right? This is the scope of that. So take it out of start here. So I know I'm going to try to spawn some number of mobs here, some number of enemies. So by default, it's set to 5. So I'm going to run a loop from 0 to 5, right? Now, that means at maximum, I'm going to have 5 of these. Doesn't necessarily going to mean I'm going to have 5 because of the following, right? I say, where should we try to spawn? And that is going to be random position within corners. So I've used random range and said, okay, the X value to spawn at is somewhere between, in this case, -3 and +3. All right. And the Y value is going to be between -5 and 5. So I'm going to generate a random vector inside of those corners. That's the first thing it does. And then it says, all right, now we don't want this to instantiate. We don't want this to spawn on anything that has a collider on it. We don't want it to be on top of anything. So to do that, we use our friend, we use a cast, just like line cast or ray cast. In this case, we're going to use circle cast, right? And so this says, all right, cast a circle into the scene at a specific location of a certain radius and moving in a certain direction. Okay. So you'll notice that for the third one, I have it set to 0 because by default, I'm not moving. I'm not using, it's not cast in a certain direction. It's really just at a spot. So I say, okay, at this random spot I thought about, cast a circle that's radius 1, and it doesn't move. It just stays put there. So what I could do if this wasn't 1, if this direction was not 0, I could say, oh, okay, and along this path. But we won't get fancy like that. So I'd say, okay, if this is false, right? That says if it doesn't collide with anything, then go ahead, instantiate a mob at that position with unity as a rotation, right? No rotation, right? So it might not generate all the mobs if I didn't want, if I could run out of possibilities here. Now, if I wanted to definitely have that many, I would have to do something like say, well, instead of a for loop here, maybe I would do a do while, and then I could, let's see, let me change this. While mob count greater than 0, and say, okay, every time I generate one of these, I'd say mob count minus minus. Now, as a safety valve, I don't like to have while loops that occur infinitely. And it may very well be, for some reason, if I generate a million mobs, a million characters, that there's literally no place for it to put them anymore, right? You may fill up the world. Who knows? So I like to put safety valves in here. Something like, if attempts greater than what is the maximum number I'd want, right? Give it some number of kind of a fail safe. 200. Great. Or I could even say mob count and attempts is less than 200. That's nicer. I like for these to be sort of explicit. Equals 0. Well, oh. And for the wrong reason. Okay. So what I'm going to do now, this is my safety valve in here. So I'm going to attempt to create, I'll do this. Attempts equals mob count times 4. That means for every one of these guys, I'm going to try up to 4 times. Okay, so this is going to decrement. Eventually, it's going to hit 0 and make sure that we don't keep running this loop forever. So as soon as this is going to run as long as mob count is greater than 0 and attempts is greater than 0. So attempts might run out, or we might generate all our mobs. All right, so let's see what happened. Let's see if that works. So over here, mobs has changed now. Mob count is still 5. We have a corner. We have a set of corners. We have a spider. Let's go for it. Now be careful with a while loop like this. So we should have 5 spiders. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. Our 5 spiders. And they don't have colliders on them. But yeah, they're spiders. And if I wanted to now, I could tune their position. Like say I only want them to be up in some corner here. So I could say, all right, let's see, I'm going to guess. And this is one of these cases where sometimes it's good to have like an extra empty game object that you can just kind of move around in the scene. Create empty. And we'll say all the spiders should start off in this corner. So they should be, X is 8.6. So we're going to say 8 and 12 and 4 and 6, something like that. Something kind of tight like that. Littman fire alarm. Wow. So 8 and 6, 12 and 8, something like that. So now we're going to wind up with, we're going to create 20 spiders. We're going to try to create 20 spiders up in a pretty tight area. What happened? You know what? We didn't give enough room. And I bet we actually ran through that whole amount. So let's create some more space. We're at 8 and 12, 6 and 8. So maybe 6 and 6, 12 and 12, and 10 of them. Oops, should have done that. Ever edit while you're running here. So 6 and 6, 12 and 12. Oh, wow, they're all up here off the screen. So, oh, I must have tried to instantiate all of them like on this boundary here, which would be terrible. So there is a bunch of spiders. And now let's create another populate dungeon. And this one, we will put our orcs. And they will be in our lower corner there. A couple of those guys. Yeah. I could even, instead of enemies, I could have it spawn anything. I could have it spawn, as weird as that would be, I could spawn Lego chests. Anything, right? Because all it's doing is checking to see what's there. So let's do that. Let's say, all right, maybe this will work. I don't know. I've never even. So we've got this game manager. We're going to create yet another, and I love that misspelling, so I'm going to keep that. I'm going to say, let's, Lego chests. Which is left over from my apple tree game. There's Lego chests. I don't know what's going to happen if I collide with them. Nothing. I just can't, So it could be anything. I mean, it literally can be anything. Remember I had my coins here? Right, my coin, which is the thing that allowed my triple shot. So let's make the coin a prefab. And let's make let's see, where's the other one? The heart a prefab. And the gem a prefab. And we'll go to our game manager. And we will add another component. And this one will be for our coins. And we're only going to create 3 of those, but they might be anywhere. So they could be from -5 to 5, 5, something like that. right? So just like if we wanted the enemy to drop something, we would do something similar to how the enemy shoots arrows. If we want them to just be spawned randomly according to the level, then I don't know why the coin isn't working. It's not creating our... Oh, I know. Okay, so one thing, if you are doing prefabs like that, the coin script that I had for the player, we have to make it a little bit more sophisticated, right? Because now these coins that we're instantiating, they're going to have a slightly different name. They're not just going to be coin. They're going to be like coin clone or coin something like that, right? So one way we can get around that is, let's see, coin. No, where's hero? Hero controller. You see right here where, right, collision name. You could say contains. All right. One of these mind-blowing ones, right? So now we can say if the name contains this string. So if it's called heart clone or heart 5 or heart whatever, gem whatever, we can work with that. Mm-hmm. Well, everything is reusable. The moment you reinstantiate the scene, you could do that. Or if you wanted, you could certainly, I mean, all these things you can, for example, if I wanted to, really mind-blowing, right? You notice the game manager is just another game object. And it has prefabs that are assigned. So I could even instantiate a new game manager, or I could call the functions. I could reinitialize these functions on the game manager, right? So that's one way of doing it. Or let's see other ways. Yeah. I mean, I'm trying to figure out the... Yep. Yep. That's good. That's certainly an option as well. So one good thing you could do, here's a use of, you may recall, we have this thing called events, right? Remember our event where we had the freak out event, right? So what if I came in here and I said, oh, okay, populate dungeon. Okay, so instead of on start, what should happen is that I should have an event in here that is start. Like this is an event. Start is an event. But right now it's an event called by the system. Right. So let's do this and let's say, okay, it was the hero, I think, that had the right. Was it the hero that had the not the freak out, but the hero was doing the telling everyone to freak out, right? Basically. All right. So we're going to tell the hero, we're going to put the hero in charge of spawning everybody. All right. So how do we do that? Let's see if that's what it was. Let's see. Was it there? Yes. Gem found. All right. So we're going to do this. We can use the same type of event. We can say, all right, we have another event called public static event, my event, and this is going to be launch wave. Okay. So now, at some point, the player, just like it would say gem found, right? Right. And let's put it in the death, right? So what if the player dies? We're just gonna like restart after all hell breaks loose. So we're gonna say gem found. We're gonna say, what did I call it? Launch wave. Launch wave invoke. So I could have also passed this a parameter. This would probably be a good case where I shouldn't use the exact same one. I should make a wave count. Right. So now I could pass in launch wave. I'm going to just, for now, it's saying invoke, and it's saying, okay, you haven't passed a wave count yet. So we'll just pass it in 1 for now. Right. This means make sure that somebody's listening. If the question mark isn't there, this is called a null check. All right. So this means only execute this, only continue if this is not null. Right. If I was guaranteed to know that there were subscribers, I wouldn't need that. But it's good to have, especially, I mean, you can use that in really just about any situation where you're checking a reference to another object, a pointer, sort of thing. And you want to make sure it actually exists. It's not null. I mean, if you did the same thing, I should avoid being fancy here. If I said launch wave not equal null, that's what that question mark means, right? That's just to make sure that, yeah, somebody's listening. So now I can also do it this way. I'm going to also say, well, at startup, boom, invoke, start a wave. Okay. So in this, where was it? Populate dungeon. I don't want to use start anymore. Right. I do, but I don't. I don't want to use start to do that. I want this to be void populate int wave. And this start here now, the one thing I'm going to want to do here, and well, actually, I guess I should, you remember our freak out script, right? Freak out class. We basically want to do the same thing here. So we'll go back to populate dungeon and do it and start. We'll do it. I'm going to get rid of that and say but the hero controller launch wave. Right. So now what we're going to do here is we're going to say every time the player calls launch wave, when it's time to do that, this is what we're going to do. Now we could do something like say, and we want to reinitialize. So we'll say, instead of using our normal mob count here, we're going to do something special. We're going to say, we're going to hide a version of mob count here. Okay. Say int underscore mob count equals mob count times wavenum. So every time we call wave count, and we should put that in there too. But every time we call this, we can set that, right? So let's do something drastic. So we'll say, for example, changing so many things. During start, we're going to set it to 1. When we die, let's set it to something big, like 10th wave, just because why not? Just to prove the point. So fingers crossed. All right. We generated a couple of these things, not too many. And what when the player dies, right? They kill the player. You're gonna accidentally bump into things a lot of the time. You're gonna get down to 0. Died. And look, suddenly there's a whole lot more coins. And everything just went really, really slow because I probably have created too many of things. It's all those spiders up there. So who knows? It might be. Yeah, we want to be careful on that one. So if we came over here, so this is bad. This is one bad thing, not one bad thing, multiple bad things. What we should do in here, because the player's dying again, right? We died. And then the next time through here, it's still negative. So he dies again. And he dies again. And he keeps calling launch wave with that many more. So what we really should make sure to do is to then go ahead and give the player some life back, at least. Or maybe we even set life back to 1. Right? Sorry about that. Right? Because we don't want this to happen over and over and over again. If this happens over and over again, we're going to invoke this a whole lot. I'm surprised my machine didn't crash. And let's, you know what? Let's make it really hard now. Yikes. All right. It's going to be really, really hard. I can only get hit 4 times, and every time I hit 4 times, it's going to like invoke that and send lots of enemies after me. So I better be real careful. We're getting into insta-death category here. All right, ready? I died. Whoa, look at all those spiders. And they are invulnerable. Ah, run away, run away. And I died. And look, there's more. Ah. So, yeah, the sheer number of spiders there, we might want to be careful about the number of spiders. That's a whole lot of spiders. Spiders never die. So let's go back to our game manager. So as soon as you start the game? Okay. What I would look out for is some sort of infinite loop then, or some sort of loop that's just causing it to bog down. It could very well be, something about the logic in, if you didn't get it just right, or even my logic might be a little bit, I should really, I'm kind of playing it fast and loose here. And it's 4:30. It's time to be done, isn't it? Yep. Sorry, I just blew past that. Having too much fun and fire drills and all that kind of stuff. This is worth going back. Places that I'm not entirely certain, or that I'm a little bit nervous about, is specifically in the Populate Dungeon call when I did this. So it certainly should be. Ooh, if you do that, then you're going to run all the way up to attempts here, and you're going to be, and potentially, if you've got enough space, it's going to be generating lots and 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 lots of mobs. In which case, yeah, that could be dangerous. Okay. All right. So that's on the fly, a quick 10-minute, 20-minute potential, kind of a cool spawn system, and kind of a, oh, I died. And Spider's back on the map. Yeah. Way too many spiders. So let's, I set them to 3. Why is there still so many of them? That's interesting. I think there's a bug in something. Well, every time I die, there's another 30 of them. So I should, maybe that's the problem. At least on the screen, so we can see a horde of spiders that we're creating. Okay, yeah, now they're. I must have like not saved something at some point. Back to life every time I get another 3 spiders. The other problem is eventually I run out of room, so I'm not spawning any new orcs. Orcs, where are you? You're really that bad? Oh yeah, there's some orcs. It's really unlucky because they're the one thing that can die. They're probably like colliding into one another as well, because orcs are really dumb. The moment they collide into something, they die. All right. Well, so they end the stream there. If you have any questions, if you have any ideas or thoughts, again, everything is sort of building on top of the same techniques now. The particle systems right now, really the particle system usage is really just as an alternative to an animated explosion. You can do lots and lots with them if you want to get more sophisticated, by all means. But just wanted to introduce kind of the main reason for us, using particle systems now or having is just to super simple way to kind of have something else that's animated, especially for explosions. We haven't gotten into a lot of the physics hinges and effectors and all that kind of stuff. That's one of the big things that we're saving for the next project. So we'll get into that next week. So believe it or not, there's still some stuff, and we haven't even done any kind of 3D stuff. But in terms of core game mechanics, you get a pretty good set, a pretty good quiver of things now. So please ask questions if you direct messages. If you have anything that's I like people questions more than people who just deliver stuff at the end that's not so great. You know what I mean? All right, take care and have a great weekend. A little bit, sure. Okay.